Welcome back to another Rust programming video. Last episode we set up this repo here, and basically we can mask out the background using the YOLO segmentation model. So today basically we want to try to get it running in real time and actually send it to a video device instead of storing it to disk here. That way I can import it into OBS and actually use it as like kind of my streaming workhorse for doing this kind of cropping. So yeah, basically if I run this, right now it's just capturing a bunch of frames, and it's going to take only the last one and actually print that out to disk. And so we want to change that to run in real time as well as do some kind of optimization work. So yeah, here's that frame. You can see I was in the middle of talking. And you can see the first thing is that the color is actually totally off here. So it looks like the model's doing the cropping pretty well, except for some of the stuff with my headphones. But actually, if I show you, we can look at this in VLC of my raw video device. This is me. There's a lot of lag, as you can probably tell, with my mouth. And this shirt is very much blue. So I have no idea what's going on with this, why the color's off. It's probably something with the color space. And so I just kind of set up the README with the stuff. First, we're going to tackle some cleanup with this color space, and then we're actually going to start writing these frames to a loopback v4L device. We'll have to create that as well. Yeah, and then finally, I guess the last part is just to integrate with OBS, right? Then I'll be able to use this going forward, like for the other episodes for speedrunning C. And I have a bunch of other stuff coming down the pike, like for doing video steganography in AV1. I want to come out with a new library. There was a paper on it before, but I'm doing it for a school project, and I want to just kind of clean it up and make it a little bit nicer. So yeah, let's fix this color space. So I'm here in, I set up the Nix shell already. We're in that. Whoops. And so first we kind of have to figure out what's going wrong here. So we're setting up the device right now with the width and height explicitly. Actually, if we go look at just kind of listing out our devices here, you can see there's only one, and it's my webcam that we're capturing stuff on. And we noticed last episode there's kind of two modes. We can either output in, this is the priority, in YOLOv8 at this lower resolution, or what we're actually doing currently. Is it not showing up here? Huh. Yeah, I don't know what happened to it, but this camera has a Jpeg mode also that we're currently using to decode. We dropped YOLOv8 because doing the conversions with OpenCV were too annoying. I thought Jpeg would just work out of the box, but apparently not. So I don't know where this is. It might be inside the Jpeg crate. Because actually the code here is pretty simple. Oh, we're not using this anymore. We can get rid of this. Basically, we create the v4L device. We set everything up here. We also just print out like what we have actually. So if I run this again, yeah, you can see we have mjpeg, which is what we're currently using, and then YOLOv8. And we basically have a loop here. We grab each frame, print out some stuff, and then we just decode these JPEG bytes directly. And then we take that. The thing is, I wonder, so my blue is being swapped for this weird, what is this? This is like what, like an orange? Because if it was a channel swap, like let's say we swapped the blue channel for the red channel, then maybe this would appear as red, but this almost tells me this is like a chroma luminance thing. Because, yeah, otherwise we would get red or green or something more obvious. But this looks like the color is actually being shifted around. So hopefully this might be some kind of internal issue with the camera or somewhere in the kernel that might be annoying to fix. Because naively this code should work, right? We're just like decoding this JPEG image. That seems pretty normal. Actually, the first thing we can try here is just kind of write out these bytes. So I think we have, basically we only set right to true after 100 frames to let the whole stack warm up. Because also when the camera turns on, it needs time to autofocus and get the parameters right. So yeah, like literally right before, I think JPEG, we don't use anywhere else. So we can just dump this out here. So as part of the write down here where we dump everything to disk, we can also just do like std fs. Yeah, creates a file. And we'll just unwrap that. Yeah, so let's run this again and grab that JPEG, see what it's doing. All right. I wonder if... I don't know why I'm doing this, guys. I don't have a good image editor. I don't really know how to use GIMP or anything. So I'm literally just using VLC to render this. Things I don't know if it can do JPEGs. Oh, it can. Nice. Okay. So yeah, this in the JPEG, it looks correct. That makes me think it's something when we do a conversion maybe with OpenCV. Or it might be inside this Rust JPEG library. The thing is, it seems pretty well tested. So let's try to dig into the OpenCV stuff first. So the file we're writing out that looks weird is, what's it called? Yeah, I think it's this masked0.bmp. Yeah. And so this is the weird one. And basically the way we get this is it's created here, and then we do the multiply between the mask from the segmentation model and the original image to crop out the background. And then we store that into masked, fixing the range, basically. This tripped me up last time. We should unwrap this. Yeah, so basically what we're doing here, this is a little weird, because this grayscale image, each pixel is only 8 bits, right? It's like 0 to 255 of how much that object is in that pixel. And we have to basically expand it out to RGBA so that we can do this multiply here, so that way the components line up, right? So that way each pixel has 4 components, so we can multiply then. Otherwise, the multiply doesn't work. So it might be somewhere in here, expanding this out. That might not work. Or... so that, yeah, then we get this mask RGBA from, oh no, that's what we're writing into. That's from grayscale. We don't have to worry about that. But the actual color image, this guy, we convert RGB to RGBA. Actually, okay, because the JPEG seems correct, I'm starting to think this is more of an OpenCV issue. I'm right is a little bit weird about how it does color formats. Because if you think about it, right, we're literally just giving it some matte. All it knows is that it's 2D, it has rows, columns, and it knows how many bits per pixel. But it probably has to assume what the format is in order to write it. There might be something in the docs about it here, actually. IMG. Yeah, so it looks like it's telling us to use convert color. And so we're writing this out as what, a PNG? Or no, BMP. It's probably going to be easier to read online. Yeah, OpenCV. I am right. Much better, okay. So yeah, we're using BMP. What? Yeah, BMP. That's interesting. Maybe it has to be BGRA in order to write out. Ah. Okay, so it looks like we have to get rid of the alpha channel. So we should be able to do a quick test for this. So we're writing out masked 0. So yeah, after we do the multiply, only for writing, we're going to create another masked RGB. Yeah, with the height normal, except it's going to be 3 channels instead of 4. And then we're going to use convert color down here. Basically, instead of writing out masked, we're going to convert masked into masked RGBA. And this is going to be, when we convert here, so this is going to be RGBA to BGR. To BGR. Yep, storing into mask RGBA, and then we're going to write out masked RGB. And it doesn't need to be, wait, why does that not need to be mutable? How is that possible? We're getting a reference here, right? Oh, maybe it's just Rust Analyzer messing up? No. That's really scary. What? What? Okay, well, let's see. Ooh. What happened here? That is not right. Whatever that is. Yeah, the mask looks right. The source image looks right, but something is very fishy here. Huh? What? RGBA to BGR. Hold on, guys. I'm just gonna put this back to masked and just see. Whoops. Just kind of see what happens. Come on. All right. So yeah, this is this is the masked one, right? And yeah, other than the color, it's right. So literally the only difference we're doing is writing out masked RGB, which is the result of this convert color. Oh. Oh no, we're not. Oh no. Guys, this is why you need to name good variables. And I had a clue, right? Remember before when I was like, oh, why does this variable not need to be mutable? Because clearly we're modifying it. No, we were modifying a different variable. Masked. Okay, once we're done with this like OpenCV stuff. Yeah, once we're done with this OpenCV stuff, then we'll be able to get rid of a lot of this like weird debugging code, and that should clean a lot of this up. Okay, let's see what this does. Come on, buddy, come on. Oh yeah, and by the way, I got a lamp for behind the desk, so hopefully we'll get better masks because the lighting will be better. Yeah. Yeah, look at this. That's totally right. Look at that color. Beautiful. Yeah, I love how it even does like these little nuances with my thumb. And you can even see the transparency manifesting as gray, where it's like it knows my hair is kind of part of the image, but it's also transparent. So yeah, okay. Let's go check this off. Fix color space, yep. Actually, we're going to leave the optimization for later because that's going to depend on how everything looks when we have it fully integrated. So we'll do that later, and yeah, let's jump right into the loopback stuff. So I got the v4l loopback kernel module installed. I added it to my Misc config, and I'll do a video going through my Misc config and my Vim config pretty shortly here. I know some people have been asking for it. Basically, we're going to use this library. I think it's included. I think it's an out of tree kernel module, but basically what it lets us do is normally v4l2 only works with like actual cameras, right? Like you plug it in, and basically this device we were looking at before of like my actual camera, this is an actual device, and so you know we can access it through dev video 0. Basically what this lets you do is you can almost think of it as like a socket, right, where you have an input and an output, or you can think of it as like Unix socket at a specific path, right, where you can create it there and then read and write arbitrarily. Except because it's v4l, basically our plan is creating a loopback device that's like dev video 10 or something, and then we're going to write our masked frames into that. And because it's a normal v4l device, OBS will be able to read from that, and then we can render that on our thing. So yeah, we got the kernel module loaded, and yeah, we're going to create. Let's see, there's a section here on how to actually create the device. Options. Yeah, we're going to want to use this with the specific video numbers. And so we're just going to call this like 10. And I think there's a way you can name these also. That'd be pretty nice. Yeah, we don't want to force FPS or the format. I think it's dynamic where whatever we give it, it should just use. Oh, actually, no, we might have to do it ourselves. Hold on. I'm going to have to think about that. But yeah, at least for now, let's create it with a message or like a name. Yeah, and then we'll have just one string for the first one, and this is going to be like, where's the space? Yeah, this is going to be like, Okay. So now that we should have a /dev/video. We don't. We might have to remove it actually in order to get it to reload. Can we just do modprobe-r? We might have to unload it and reload it. That might work too. Oh. Oh, before L2 loopback. Okay. Now we'll try to run it without deleting it. Oh. And we need sudo. Okay. Yeah, so we got our video 10 device. If we do v, we have it in our project here. --all. Hopefully we'll see it in here. No, we don't. What's the help for this? I think there's a way to print a particular path. Oh, ---- device. Okay. Can we do 10? Okay, so maybe it doesn't exist because it has no parameter setup. But we should be able to write into this regardless. So we're going to have to figure out how to do that with the Rust library. v4, I think it's just v4. Yep, this is it. Yes, we're using this guy, actually almost this exact example, to read in the frames we pass to the model. We're also going to have to figure out how to write to the frames. So there should be like a struct for, nope. Capabilities, it should be their like device struct. What do we call it in here? Where we create it. Dev, what is this? Yeah, it's just a device. Here we go. Yeah, so we're gonna want to use with path because it looks like this one we get by default. Oh no, we do use the device number. Okay. So this is gonna be, we'll just rename this to webcam. Webcam mast, sure. I just want to run this and see if it crashes or not. No, it looks like it works. Okay, so that's good. It looks like, I think though if I make this something that doesn't exist, it should. Yeah, okay, nice. So it looks like you can find the device. I don't know, yeah, we might have to set those parameters explicitly. We'll find out. Actually, we should be able to do that now. Let's create it down here. And we'll do webcam mast set. Where's the resolution? No, we'll just do. Yeah, we'll do basically the same thing here. This needs to be mutable as well. This will be mutable eventually. Yeah, because basically we just do the masking, so it's actually always going to be the same resolution as the source one. Eventually we'll make this dynamic where it like picks the best one in case I upgrade webcams in the future. I definitely will. And then we figure out this, right? Because we're going to want to use like RGB or RGBA. The problem is I don't know if that's actually supported. I saw there was parsing code for this somewhere. Oh, maybe probably in colorspace. Yeah. What is sRGB? Is that different than like RGBA? Yeah, what's going on with this? Yeah, this looks right. So I think these 4 values are just the same as what we're seeing here, right? Where this is literally just 4 bytes. Let's see about this guy. Interesting. White reference. What is that? Okay. Yeah, we don't want to do this CBCR crap. It's super annoying to encode. the thing is this white reference, this third S parameter, I'd assume that the webcam already normalizes this, right? So we might be able to just pass in like 1.0 or something. I wonder if there's more info on white reference. Yeah, that looks normal. Oh yeah, what is white reference? Perfect. Huh? Yeah, I remember hearing about this. You know, maybe we can just leave it as 0 initially. Maybe we can do it with OpenCV. I mean, they look close enough. Like, I don't care enough about the format. Like, literally whatever value we can stick in there to make it work is what I want to do. He's using convert, though. No, I don't want convert. I want OpenCV, bro. What is XYZ? Oh, maybe we should do RGB to XYZ. Do they have that? Let's hope they do. Oh, interesting. Okay, let's see what this says. Oops, we really want RGB to XYZ. Things I don't know what this Y component business is. Because it's almost like XYZW. We should just keep these docs open, honestly. No, it's the same thing. You know, maybe these are just the color spaces and the color format is different. We could also encode back into Jpeg, but that adds a bit more latency. What is raw, though? Raw. Yeah, let's not do raw. Honestly, let's just try srdb and see what happens. Yeah, let's go back to the docs for this guy. Yeah, so we create the device. I wonder what this is. Oh, this is just a low-level FD. So yeah, we'll set the format. And then output. Yeah, this is what we want. It just implements the normal, right? Because so the problem is we're using this method to get the timestamps and some other info. Where is it? Yeah, stream.next. Oh, we probably have to use the stream API. Is there like a stream.write? You know, maybe they have an example for this. Otherwise, they might not actually support it. Yeah, this is only reading. Forward, yeah, this is what we want. Okay, so they create two devices, that's good. This sync thing is what we care about. Okay, we got to watch out for this. Create two streams for each one. Grab the next one. Okay, nice. And then where do we actually write? Is it on drop maybe? Because it looks like we simply just copy it in. There's no timestamps either. That's interesting. So yeah, we want buff out is what we copy into. So yeah, we want anything to do with out, we want to copy. Cap, yep, out, out, out. except we definitely don't want to use the source format. Yeah, I would definitely have to clean up this code a lot. It's getting pretty ugly right now. What's this? Hold on, what was this called? Okay, so color space is different than for CC. We're probably just going to leave this at the default then. Mem0, that's interesting. Is this like a low level? Oh, reprc, makes sense, yeah. That's cool, I didn't know you could use this as like a default thing. Curious what this is too. Nice. This is probably what we want. Yeah, this might be just for our camera though. Because for the loopback device, it should be more agnostic, right? These are, I think, only the formats it lists. Oh, or maybe we can just convert it to YUIV and send it and hope for the best. Yeah, actually, that's probably the easiest. And we already have... Where do we create? Oh, here, yeah, webcam. Ah, whoops. We definitely, this has to be all webcam masked. Oh, we have to use the trait explicitly. That's fine. We're just printing here. We don't really need this to be imported nicely. Okay. So yeah, we're gonna get the... This is gonna be webcam. It's gonna be masked. And we have to copy this path again. And we can just panic here. Oh, except, whoops, so... Nice, these are macros. Okay, and we'll just return here. That. Line 69, nice. So it looks like the default format is totally wrong. So really what we want, it's probably to do with this 4cc thing. So we should, honestly, let's leave this as the default. And then the other parameters we want to change here are color space. Whoops, not color space. Yeah, maybe it's 4cc then. Color space, color space. That's the whole format. Oh, here we go. Okay. Oh, and this is 4cc, yeah. So what we want is like, what's the easiest? RGB 24. This is going to be RGB 3 is what we're going to call it. Yeah, and then we should be able to dump it, the pixels directly, right? So let's bring this back. This is just a byte string, yeah. RGB3, nice. So now this should no longer panic, hopefully. Yep, okay. And active out format. Yep, RGB3, this looks correct. Progressive, stride, that seems reasonable for these. This, and defaults. So yeah, that looks good. Caps are empty, probably because it's default. Oh, new. Ooh, that's for the masked one though. We don't want to do that. How is this Jpeg? That's not right. Oh yeah, we already set the format up here though, so we shouldn't have to mess with this at all, right? Yeah, we get the source and set it directly. We don't want to do that anymore. And let's just clean up some of this printing that's like, make this all input formats. Out, out, out. Okay. This should be better now. Okay, so it looks like the out format's RGB3. Our in format is still going to be Jpeg. Yep. Cool, so we should be able to write to this guy now. And so the way they did this in their example was what? So we need an out stream. In stream, out stream. Oh, we're going to want to switch to an mmap stream. I wonder if we'll have to change this at all. Come on, LSP. What are you doing? It's probably in the same format as this, right? Oh, maybe there's examples out of date because this is totally the mmap module. Does this call mmap anywhere? No, it's probably somewhere lower level. Drop. Yeah, let's leave this for the optimization section to just double check we're actually using mmap. But yeah, we definitely want stream. It's gonna be masked, and we'll just make this a nice variable for this guy. This returns, yeah, okay, it does return a result. Why is this unused now, though? Oh, these are returning. Duh. And outstream. So yeah, outstream is going to take in just RGB. So once we do the multiply, things though, maybe we should do this multiply in RGB, because the thing is we don't actually care about opacity, because we're going to set the pixel values we don't care about. Oh no, we do. We should do this with RGBA instead. Wherever that header file was. Hopefully I didn't delete it already. Nope, okay. We want like RGB32. Okay. What? I love this for CC thing. It's really funny. So we're going to have to convert to ARGB32. I think OpenCV should have a function for that. And we'll have to modify this guy to use the actual one. BA24. That makes no sense why it's called that, but oh well. Programs are never good at naming things. BA24. Yep, okay. So now we should be able to write, get a buffer, and then write out our stuff. So we got this outstream in this example. Okay, yeah, so it looks like we'll just have to assign meta. And so every frame we get from this one, we're going to also want to just kind of queue up a new... Oh yeah, their traits are messed up. That's why they have to do it like this. And my Vim is lagging. What is this type? This is... That's really annoying, guys. Huh? I don't want to do type aliases. I just want this to work. Oh, we should use the prelude, actually. That'll make things nicer. Yeah, so it looks like, I think they always have to use, like when they create this, can they refer to it? Capture, device, capture, output. Yeah, video output, okay. We do need type. Wait, so when they call next, oh, capture stream, duh. And then this can be output stream. Does that not exist anymore? No, it's a trait. It's weird. Whenever I copy paste, it really lags out. Okay, that seems to work. It's a little awkward though. So yeah, these are mutable, and we're going to be writing into these guys. We'll probably have to do another hack with the slices here. Yeah. So here, once we do the multiply into... Got to get these variable names right. I messed up before. So we multiply the mask with the source image into masked. Here, then we're going to... Whoops. And this is going to be masked. Masked. All masked, okay. And so now we have this slice. We don't want to own. These are just going to copy it. And what do we call these? Buff out. Okay. And they had some weird math for making this the right size. In buff.len. Ah, okay. So yeah, we'll do something similar here, where we'll just create like a, yeah, so whatever length, yeah, mass data has, we'll just make a slice that's the same length, because actually copy from slice, if the lengths aren't equal, it just fails. So this is fine, you're right, because then if you think about this, if len ends up being longer than this buffer actually is, then we'll panic because this will be out of range. Otherwise, this should be created correctly since we're using the pointers from OpenCV, and so that's why this is safe. We'll go through and do like safety comments and error handling and that kind of stuff in a bit. So yeah, we copy into the buffer. It looks like as soon as it's dropped, it'll send it, right? Like I don't think there's anything else. They don't do like device.send or anything like that. Yeah, and we'll just copy all of this for debugging. Yeah. Call this, and we can get rid of this. Oh, and for this comment to be correct, I'm actually just going to change this. So we make a smaller slice, that way the length is correct. Okay, and then it looks like they assign to bytes used. Yep, that'll be important. Copy from slice. That's interesting, it's always 0. I guess if you're sending frames in the future or something. And this isn't going to be buff in, right? Because we're using a different format. It's actually going to be len, because that's how many we're copying to. As U32. And yeah, I just want to run this and see if it crashes. It crashes, okay. And it's somewhere with a question mark operator. Huh? So actually, this is why I don't like using question mark when prototyping and using unwrap, because we don't get a backtrace of where this is happening, right? Basically, every line in this code base could fail, and so we don't actually really know what's going on here. And anyway, we'll want to use like anyhow to add like a context line here, so if it does fail, we know why. Okay. All right, that's reasonable. Okay, line 90. Let's see what's going on. Invalid argument, interesting. So maybe we have to set something with the caps here, because when they create theirs on out, maybe it has to do with this, where the format's not set or something like that. We use device with path, we use device new, that should make a difference. Oh, maybe we should start with this. No, we should just use our own, actually. So we don't need this. We don't need this after. Thing is, this really should be mutable, right? Because when we're... Oh. What? Is this not always mutable? Huh. Okay, maybe we have to create the device differently. Capabilities empty. Maybe that has something to do with it. Interval 1/60, 1/30. And so what syscall is this actually doing here? Arena new. It's probably in here. Request buffers. And this is what, invalid argument? Yeah. Maybe we have to create it with memory. So when it sets this up, it just says count. And this will set the type and this to be mmap. Buff type, what is this? Or it might be failing here as well. Oh no, so this is requesting each buffer and mapping it. So I'm going to assume it's here. Although also it's hard to tell with their use of question marks and no context. Yeah, so it looks like the capabilities are here. Active out. Oh, it looks like it resets after this. Yeah, maybe this might be getting set to none when we reset it. Yeah, so we query it here. Oh, the parameters are probably different than the caps though, right? Oh no, maybe the caps are? What? Looks like time per frame is the only one that's supported though, right? And so like up here, when we set, what are these capabilities? Okay, this is flags. Yeah, loopback, output. And these parameters, we probably want to just copy from the active, right? Yeah, we're going to want to set this interval to. Okay. Yeah, so we should be able to set the FPS through this. Because up here we set the format of each thing, right? Whoops. Oh, what did I just do? Yeah, this guy is the format set because it's a webcam. So the device itself sets that over USB, I think. So this is as capture. Params is going to be Are these really the only methods? Params, set params. What is this? So maybe we can't set these capabilities at all. That might be it. We might need this actually. Okay, maybe this is it. And we did -r. And we're going to create it. Exclusive caps equals 1. You know, that's why it concerns me, right, when I do all. Yeah, so it does auto exposure, but the problem is we're only getting our camera, right? We're not actually getting the loopback device. Huh. Yeah, very odd. We should set this to 60 FPS though. So it looks like we can only set params. What were these logs doing again? Yeah, these end up being empty for this guy. However, for this guy, it's totally set. Yeah. Oh. Oh, we do, okay, we can do set params, that's good. And so this params struct right? What does it have? The caps and the interval. Okay, this should work actually. So, except actually we want to call it, I'm totally calling it the wrong thing up here. Oh, and we can use this. And let's make this a little more rusty. We don't need all these dumb new lines. Oh, actually, no, we do, because these are, it displays them as multi-line. Okay, and then we're basically going to change some stuff and then do set params, loopback caps. This can be mutable. We're going to change it. Okay. Oh, and we can... Do we actually need this? Oh, we do, unfortunately. Okay. We don't need to enumerate it, though. Hopefully I don't just immediately break this here. That's still Luma? Okay, cool. Yeah, just trying to clean this code up a little bit. So, interval. So it's going to be 1, what are these fractions? I think it's just 1 over 60. Do we have to unwrap? Nope, nice. Yeah, and then hopefully we'll still get this. I wonder though, if we log kind of the same thing. What do we call this? Active out. Still panics. So our interval changed, which is good. It's still very sad though. It's all this stuff. This is right. What was that function we were looking at? You know, maybe it doesn't support mmap. Actually, is that an issue on the GitHub? Huh. Yeah, it's nice when this kind of dev works on GitHub instead of on like the mailing list or something weird. Here we go. This might be it. That's interesting though. It looks like they're getting an actual loopback device, whereas we're not. Oh, actually let's do this. Yeah, so we're gonna write video 2 to video 10 and just see what happens. It looks like it's recording. Now if I open video 10, okay. Interesting. So yeah, it's definitely something in our code then. I wonder what FFmpeg sees as the caps here. So it looks like raw video, that's interesting. And it looks like it's using YUV. I don't think that would be the issue though, right? Oh, maybe, so because we're using, what's our format again? It's this weird string. Yeah, BA24. Maybe it doesn't support this. Okay, so it looks like these defaults are totally wrong. That might be why it's failing. Yeah, I think we might have copied and pasted too much code. So this is everything to do with webcam here, right? We set the format. I'll move this outside. What the hell? Yeah, and then we'll put all of this, once we create it, in here. Set params. Yep, everything up until the buffers, just to make this a little cleaner. So we get the current format, which is probably wrong. I hope this stuff gets recalculated. Thing is, it looks like it does for this, right? Where's that? There's that beware of dragons here. Oh, we're not setting the format. Yep. Oh no, we are. We should do this check though. That's why. Yeah. Oh, these 4 CCs are going to differ, though. Let's see what this says. So, this is source format. 1280, 720. This should be Jpeg, progressive stride, flags, and the sync format. This looks correct. Why is the stride different, though? Yeah, default should be good for us. The size is still really massive. Is this stride any different? Huh. This might have something to do with their internal representation. Caps empty. I think the caps are empty up here for this guy too, right? You know, maybe the V4L has some examples. Oh, they do. I'm gonna have to run this code. Thing is, they're reading. Oh, they write and then they read. Okay. You know, instead of doing this sync stuff. Wait, so this is panicking, what, 103? Instead of doing this, I wonder if, and we don't do this. We literally just do that's outright. And we're going to use the trait. Now it needs to be mutable. All right, what about this? Oh, okay. Initializing the model. And we can't write. So this should be failing. Yeah, this is failing on the right now. That's unfortunate. We might have to set the type somewhere. So I think the only other place we were trying that is here, which was failing. Oops, no, I mean outstream. Oh, maybe we can use new. Oh no, this is doing the same exact thing. So if we do this, it should fail on line 104, right? Okay. I wonder if I set this to video capture. I think we're just creating the device wrong. Yeah, because that also fails. Yeah, loopback. Read and write. Video output. Yeah, we're trying to do video output. You know, this might have been because we reset it. Because now there's a couple in here. So mob probe, remove. Where was that massive command we had? So yeah, I think when I remove the device, it should, video 10, yeah, it's gone. So this is the command we're using to create it. Exclusive caps 1. So if I create it like this, let me get the caps. What are the defaults? These look all reasonable. So when we run it, fails of course, but these are changed. 1280 by 720, BA24. These bytes per line look totally different now. Okay, because it was 0 before. Interesting. What even is this size, right? So it should be 4 bytes per pixel. Yep, okay, that looks right. The stride is a little awkward though. Is this might be doing something. Is there even a stride? And so this should just be the width. Yeah, that looks right. These are defaults. Yeah, that's fine. It got changed to 60 FPS. That's good. Yeah, guys, I'm really stuck. I don't know. So this is the ioctl that I think is failing. Oops. Maybe this is in here somewhere. Are we getting, is it invalid argument? Yeah. Hmm. Yeah, this is the same ioctl they're using in the Rust code. try to compile this. What are we missing? Oh, all the header files are in here. Nice. And this is going to be video 10. So it looks like the mset's setting it to 0. If we try this with 4, I wonder. Whoops. Oh, and we need a new line so the buffering works. Huh. That's odd. We're getting a 0 length buffer. So this should be setting, yeah, this is setting it to mmap, which is 1. Yep, that's 1. You request 4 of them. Buff type video output. Yeah, we're setting that to output. Thing is, why would this length be 0 if bytes used is larger, right? Oh, so the length for single plane buffers. Let's see if we can map all of them. Okay. So then, if this code should be the same, why is it failing? You know, I wonder if we, now that the format's set up, yeah, yep. This all in theory should be correct. So if we, after we create it, if we just do literally nothing, even the frame rate's right. I wonder if this will work now. Valid argument. Nice. You know, let's download this crate and mess with it locally. That way we can debug this a little bit easier. This is gonna be // oops. Oh, it's gonna be this path. Hopefully this should work. Yep, okay. So now we can edit this code. And really what we're after is going to be stream. mmap arena allocate. Okay. This makes it a little smaller. Doesn't implement debug. We can fix that. v4l2 request buffers. Where's our struct? Oh, it's using macros, bruh. Okay, that's fine. We don't need to log it then. We just have to know where in the code we're failing so we can isolate it to that ioctl. Ah! So it fails on 106. So it's still in here. Oop. With buffers. What other syscalls do we do in here? So we call allocate. mmap. Oh, is it mmap that's failing maybe? What are you crying about? Oh. What? What did I do here? Oh, there we go. That was it. Things, why is this doing it twice, right? Oh, this is probably for the first one, and it fails it when I'm mapping. Let's actually... Okay, so yeah, this is definitely during the second one. It maps and then fails. Oh, so this buff length is probably invalid. That would probably be why it's invalid. Okay. Interesting. Yeah, so these other lengths, this should be... That's a big length, yeah. Yeah, this is unrelated. Yeah, let's try using YUV. It seems like this is what? It's either close to the format we're using or it's the exact one. Let's move this somewhere else. It seems like the YUV formats are better supported, so it'd probably just be easier if we switch to that. Problem is we have to find these... Oh, whoops, no, we want loopback. Gray, 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 2 planes, no. YUIV. This should be easy to convert to an OpenCV. And we can see if it works a little easier. And yeah, we do want to actually run this now to set everything. Nice. Okay, same problem. wonder if there's any other hints in here, maybe. You know, let's just try their exact example. Okay, we can just steal the shell from here. What did I call this? Webcam. There we go. Oh yeah, I guess sys needs libclang probably to parse the header files. Oh, interesting. So yeah, it probably is something with our device then. Unless it's gonna be video 10. Whoops. What? This is undropped, that's fine. Probably because it's still, the frames are still being used internally when we try to drop it. I wonder though, this is, yeah, we print that. Wonder if this will fix it naively. Nope, okay. Oh, maybe because it existed before, then this won't work. So then now these lengths are correct. Okay, both are being set to mjpeg though, which isn't really what we want. The thing is, if this is working like this, we might have to re-encode to JPEG. Yeah, let's try that actually. If we can just copy the JPEG images into the simulated device. So this is going to be JPEG. It's printing out the buffers. Okay. Yeah, I wonder, so if we set it to be mjpeg, what else do? So they do this format stuff. We're also setting the format here, so this shouldn't be a problem. Okay, so then down here, oh, we're just testing if we can create the buffer. Nice, same thing, okay. Yeah, so something's totally messed up with our device here. We should just do the same thing and copy the input caps. So yeah, instead of doing all this with the parameters and stuff, let's just so cap, that's going to be webcam, and then anytime it's out is going to be webcam masked. And we'll make this a panic. And we need this here, and then we need out as well. let's try this. Ah! Okay, so something was nasty with our format. So yeah, for now, let's just Jpeg re-encode. Yeah, so we were able to create the buffers. That's good. Looks like it only created 2. Oh, for the input device, yeah, it probably only needs 2 because it's low latency. Because really having all these input buffers are only useful for our program itself. If there's latency, we can buffer the frames and keep processing them. But I mean, for the input, it's going right to the kernel, and the kernel probably has its own buffering. And then there's multiple buffers on the OBS side where it's reading it. Okay, so yeah, we'll roll with this MJPEG, that's fine. 1280 by 1080, new out format. Okay. So hopefully this Rust crate, we can also re-encode JPEG, because I don't want to have to bring in a whole new thing. What is this crate called? Zune JPEG. Ooh, this might be only decoding. Decoding, yeah. Might have to switch to Turbo JPEG for this. I wonder how fast this crate is. Hopefully it has, nope. I was going to say hopefully it has a lot of stars. Yeah, let's use Turbo JPEG. And we'll need the Nix thing for it. Okay, so it gives us, it looks like this lib. And it's SIMD, nice. I'm going to cargo add this bad boy. Let's see if it builds. Nope. We need CMake, are you kidding me? Why would we need CMake? So gross. Okay, at least it's seeming to build. Nope. Okay, now we'll probably need the library. We need... Why would we need an assembler? What is this? Come on, buddy. Come on. Yay, go team. OpenCV's rebuilding. Yeah, it seems like there's a caching issue. I've seen this before. Oh, probably because our environment changed. It has to rebuild. That's probably why. And let's just keep this kind of nice. We need that for Rust. Okay. Seems like it works. And we want compress image. Perfect. Hopefully this isn't a pain to construct. We can just do... Oh, it's image. Yeah. Okay, so we'll probably have to pull this back out into one of these image types from the image crate. We can just use from raw. Yeah, and it's RGBA. Yeah, we definitely want to use RGBA for this. Okay, so once we have the data, we're going to compress it. Or no, we got to create that fake image. RGBA, and this is going to be mass data, and we're going to compress. And what else does this need? Quality. Let's do like 85. Oh, actually, we can do a little trip down memory lane here. I did, for the science fair, I did analysis on some different formats and compared some Jpeg stuff. What did I call this? Science fair, yeah. Way back. Did I even write a README? Yeah, with my garbage writing style. But yeah, so these are the different levels of Jpeg. This is, this would be 90. And if we look at like 40%, you can see there's some visual artifacts here. If we go to like the lowest one, yeah, it looks really crappy, these colors here. This still looks good, but you can see there's a lot of haze and weird stuff going on. This one's like really garbage. Yeah, level 0 is like disgusting. Yeah, it's a tiny file though, if we look at the size. So usually somewhere around 80 to 90-ish% is a good trade-off between size and quality. So we'll stick with that for now at least. Oh yes, we want to do subsampling. We'll just do like a normal, like 2x2. Oh, this is gonna affect. Honestly, because we're giving it a JPEG, there's so much information in the header that the kernel should be able to figure out what to do with it. And so this should give us what, like a vec back? Result own buff. Okay. Masked JPEG. And this should hopefully like deref or something. Yeah, perfect. So instead of doing this right, we're gonna do hopefully this buffer for MJPEG, it should know that it might be massive, so it should allocate big enough, and then we'll set this stuff too, except this is going to be mass JPEG.len. Because yeah, this is just for accessing the mass data, this len. Whoops. Hey, where'd my program go? There we go. Man, I thought this was going to be easy. Oh, and we should, while we're doing this, we might as well benchmark this. So once we run inference, oh, this is, we're going through every result. Yeah, we're going to give a frame for every result, which is not what we want. From raw. To owned. First. Yeah, so now this will only run once, which is definitely what we want. Yeah, we clone that, and we'll figure out the timestamps after this. Huh? What do you mean not found? 1.01. Did I add the wrong crate? This is 1.01. What do you mean? Oh, maybe we have to set features. Oh yeah, we want image. Does this have a feature requirement though? Yeah, I see. Okay. That makes sense. Turbo JPEG. Image. It's going to rebuild. Nice. Deref, come on. Okay. Model's warming up. Okay, this is the moment of truth, guys. Video 10. Ooh. Okay, maybe we probably shouldn't. So it looks like as soon as we opened it, we got device or resource busy. I think that's because we created it with that other flag. So let's remove this. And then we're going to re-add it except without this. Hopefully OBS will be smart enough to pick that up. Come on. Yes! Let's go! Okay, it's a little glitchy. Oh, it's very glitchy. So actually, we're going to switch this back to be... what version did we have of this before? Okay, yeah, we're going to use that version because I changed this to panic, and then we should start handling some of these panics here. It did run strong for at least a couple seconds, though. I'm going to start it later once it's the pipeline gets flushed after the model initializes. Okay. So this looks better. It still panics. We'll have to... So maybe it's because we're giving it too many frames or something. Panicking in an arena, though. That's not what we want. Did this not save before? Woo. Actually, we are going to have to use our local fork and fix this. So this is panicking arena 139. This is on drop, though. That's interesting. Why are we dropping an arena? Oh, because... duh. We're only doing 100 frames. So, no. We want this back, actually. And let's get rid of this annoying, like, loop and write. Actually, before we do that, let's commit. In case we have to go back. Remove image. Okay. And then anywhere we're writing, we're just going to get rid of this. This will make it a lot faster too, because ioctl kind of slow. All right, let's try this. And we don't want this break. Yeah, we'll have to handle this. We might just want to, honestly, if the process is exiting, we'll probably just stdmem forget it. Come on. Yay. Yeah, I want to try and break this. So, like, if I hold up my phone here, it's starting to pick up just the phone. Probably because it's, I think, whatever object it can see best, it's going to look at. So a lot of times the segmentation models will give you the type of thing it's seeing. Like, it's trained to know, like, a cow from a dog versus a phone versus a person. So probably the easiest thing to do would just be to say, hey, what type of bounding box or what type of, like, detection is this? And then only if it's a person we display, because right now we're just grabbing the first one. And so if it finds only me in the background, then great. But if it finds, like, an interesting object, right, it's going to jump right to that. And sometimes it'll jump back and forth because there's, you know, the quality of detection is always changing, right? So if it's like, both me and the water are visible, but if it can't see the water well, it'll jump to whatever's the next best thing. Those edges look really nice though, like on the water here. Oh, let me hide. This is really glitching out now. I have to like hide my, yeah. But when it's just me, like there's not much in my backroom or my background, this looks pretty good. Okay, yeah, let's try and fix this. Oh, also I want to see the processing time. Start. No, so I don't want to get lost. Let's just do performance later. So what we want to do is find the best detection, right? So when we run the model, it gives us a vector of all the results it finds. Each one, we don't want a tensor. Oh, this model might not support it actually. Oh no, there's this ID, which I think... Yeah, where we create the bounding box. What's this ID? Because I think there's somewhere there's a list of all these possible IDs. I actually might have deleted this from the original demo. Yeah, we want the GitHub. Yeah, so see how in these, it's able to tell what kind of object this is? I believe that's the ID field, and so we just have to figure out what, this is obviously names. What are names? This might be what we want, actually. What is this? Oh. Yeah, this is what we want. So person looks like it's the first one. We're going to want a nice way to do this, though. So up here, let's do like... So let's enumerate this, dot find, we'll do find map. And so basically this is going to be like the index and the name, right? And so I think find, yeah, the closure returns an option. So if otherwise it's none, right? And then we'll expect model not model person yeah, and then down here we should be able to actually print out what kind of detection it's finding. Yeah, so we can just do model.names. So part of YS is there's masks. Oh, there might be multiple bounding boxes that are different things within the same detection. That's going to be very interesting. This can be like model.names. That's a vec. And then we're going to basically go into that by, or no, it's going to be ys.bboxes.iter.map. And we're going to index that into bb.id. That should be a thing, right? What are you crying about? Oh, this has to be a tuple. On vec of bbox. Wait, this is... Oh, option of vec. Let's not do this. It's gonna make a lot of stuff break. Yeah, we're just, there's no need, it's a vector, like, the vector tells you if it's empty, right? So there's no need to have, like, do this weird jump business. And we can do the same here. Oh, except this is no longer this, and this is no longer this. Oh, are you kidding me? Is there like a dumb method for it? There is. Let's get rid of that. And then all the non-math ones can go away. That might break more stuff. Yep. You know, I guess it's nice to have this like parity where you can just add this for the width. Yeah, let's keep width and height. That's fine. But the other stuff I do want to be able to access. Come on, bar checker. What's going on here? Oh, and then we can just reference this. All right. Because most of the time there should just be 0 people, right? We're going to have to remove all this other debugging for now, just so I can see what's going on. So yeah, we want the detections, but then all of this has to go. Yeah, we'll just remove all the other debugs in here. Okay, that should do it. All right, come on. Come on. What? There's still crap? Yeah, so detected person. This should be much easier to see now. Yeah, so detected person. I wonder what this will do. Person and cup. So yeah, basically we just want to find, so it looks like it's giving us one YOLO result. Oh yeah, because there's one input image produces one YOLO result. We only get a vec because we're giving it a vec of images into it, right? Because basically that'll allow the GPU to run more stuff in parallel. Oh, and it's doing a chair too. You can see my chair. This is funny. What is this? Does it know that this is a fork? Toothbrush. Yeah, so we want to basically use this to our advantage to go through the detections, right? And so we're going to do like So we get the first thing. And so we're gonna have to actually, let's find what are we gonna call this? So the YOLO result is this, right? There's one embedding from running the model, right? Maybe with multiple objects coming out, and then each of these are vex. So what I'm thinking is we just have like basically an index. So once we get the first thing, so if let sum, what do we need? I think it's just the mask for now, right? We do use the B boxes. Equals, this is going to be like ys dot mask dot get at person index, and then ys dot b boxes dot get person index. Right, and then we no longer need this, because I don't think we were using I at all. Okay, and then the way we're going to find the person index is it's going to be basically this code. So let's do like, or no, it's going to be like okay, so we map the IDs here. We don't need to collect. This is our new iterator. So now we can just do dot find. Let's do a flat map. And so this returns our filter map. And so now this can return an option. And so, yeah. This is going to get a little more complicated here. So we get the bounding box. And so except this is going to be dot. And so if actually we don't need this, we just need dot find. We don't need to enumerate anymore. Oh, and then this all simplifies down. Yeah, so we find basically the bounding box where there's a person index. Yeah, let's see what this does. And yeah, find will give us the option already. Returns and but this should reference the stuff inside of it, right? Yeah. Ah, okay. And so, so we'll do like equals that diverging branch. And let's just collect this anyway, so it's nice. Yeah, actually we can literally just do all of this up here, just so we have it nice to go. And then finding is going to be really easy. That's literally just detection names dot iter dot find. Why are you sad? Iter. Oh, we need a bracket. Oh yeah, that's where our bracket went. Oh, what am I doing? Name. Now this should be a usize that we can index on, right? Yeah, this is B. Yeah, maybe because we're using there's another, what's it called? There's another API. I forgot what it's called. It's like first, or it's like find. Yeah, we want the iterator trait. So find gives you the item. Is it? I think it's just literally a function called index. Position? Yeah. Yep, that's it. So instead of find the position. Now this is a usize, and this should work. What? Oh, this is, oh, these are inner options. I'm getting really crazy with the brackets here. That would do it. And we'll reference this again. Whatever, we'll just clone it. No, we don't want to clone all of those though. All right. So if I hide, yeah, no person found. Here, let's let me give you a view of this. So it should be smooth now, and if I hide, I should just disappear. That's another thing. We're gonna have to make sure to send black frames if I disappear, so it doesn't get stuck like that. Because if I get up and walk around and leave, it'll freeze. Yep. So I'm out of frame now, but it's frozen. If I come back, now I'm back. And it's fine. Also, the latency is kind of high. Like if I clap, yeah, it's pretty garbage. And then there's the same thing with like, yeah, there's some weird spots around my headphones and stuff. I can try to slowly improve that though. We can always work on integrating a new model later when we need to. Thing is, these latencies, the video looks, yeah, there's a lot of latency, but it's decently smooth. But it looks, oh, I guess if we're only running at 50 FPS, this might be fine. Yeah, if it's steady state. Yeah, because if we get a detection without a frame, right? or without a person, this latency is going to shoot up. This might actually just be us blocking for the next thing. So yeah, we're getting closer. So what's left then? I totally just lost my train of thought. That's another interesting thing. If I make like a circle, it's a little glitchy. That's all right. Okay, so I think I can see the bounding box cropping becoming an issue, actually. There was some logic there where the top of my head is... There was like one edge case I hit where the top of my head, yeah, see how it's kind of flat? So the top of the camera is actually up here. But if I sit just the right way, you can see there's a couple pixels at the top of my head. Yeah, oh, you can really see it there. They're getting just truncated off. Okay, so let's try and fix that. And then we'll send the black frames too if there's no detections. And we'll refactor this to make it a lot nicer. So in model, there's... we basically crop the mask to be... Yeah. I wonder how many conversions we're doing here. We just kind of want to push these bounds out a little bit. So it looks like we loop over every pixel. And if X is lower, so if X is outside, where do we actually create this? No, we don't want to modify it here. We want to modify it where we actually crop it. Yeah, so we'll just kind of make some variables here that override it. Make the padding like 10. So we're going to subtract by 10, and this is... Okay, it's floats, so that's all right. That'll work. Y max. Y, min max. It's going to be plus. Oh, this is X max. X min, yep. Come on. Okay. So now this should be a little better. I can't remember how I was able to replicate this best before. Thing is, if I don't see it, then it's probably fine, you know? Yeah, it looks a little better. Okay, so let's clean up this code now then. So what is the nastiest part of this? Let's commit this actually. Yeah, we can basically delete it, all the commented code. Let's create the output device. Create buffers. We should switch this to be, what's it called? If we're using Turbo Jpeg already, that's a little bit more of a well-known library. We should switch to using their API. So there's what? Decompress image. Because I think this actually gives us yeah, it's an image, but we can just reference the bytes directly. And yeah, all it takes is JPEG data. That's good. Pixels. Auto deref. I don't want to have to convert it to a vec though. We might have to do that though. This should, yeah, okay, this won't cause us to reallocate. That's good. So yeah, we get the pixels. I think it was a slice before. What? No, we don't want slice pattern. Oh, actually, hold on. Now that we have write access, we can just keep it as a vec. I think the vec has this method. And this is going to be the image type. JPEG pixel. Okay. Oh, it's a trait. Okay, what's it implemented for? And then this is UV3, so actually this needs to be RGB. Yep. 3 elements. This should all be correct. Oh, and then this does need to be .cast. Okay. Where are we getting warnings? My LSP is really angry right now. Oh, yeah, this should be padding. We don't need this. We don't need fraction. We don't need June anymore. Yeah, it'd be nice to use the all Rust one, but if they don't have decoding support or encoding support, that kind of sucks. Nice. We will never drop this because we're always in a loop. That actually fixes that problem. So actually now we don't even need to search this. So these are all the detections. Iter dot position. And so this is going to be if bb.id. We need to delete this method ASAP. And then these can go away. Oh, and this needs to be a float. Okay, where else are we getting warnings? Let's just get Clippy to fix everything for us. Oh, and where's Zune? I want this example to keep working so we can just reuse this code where we decode it. Okay, this is gone now. Hi GUI, that doesn't work. Okay, that looks good. That looks good. So no warnings, but this code is still pretty gross. So let's handle the unsafe now. Yeah, because basically offset from is illegal if it doesn't come from the same object, right? Yep. Doesn't wrap around. Okay. And we don't need a 1. That's really the only one that's important. We'll want an assert here that width times height because this is grayscale. Yep. By assert above. Just make it more explicit that we're not chopping off important bits when we downcast. Okay, that covers this. Yeah, this is just allocating memory. We're not giving it any pointers here. And then this justification is the same. And this one. Does this create, is this expensive to create? Oh, it has a handle, yeah. Okay, so we definitely want to use, we want to create this compressor ourselves then. This should be pub, yeah, okay. So outside this loop equals new. Yeah, nice. And we can use this for both compressing and decompressing. Thing is, what can you do with this though, right? Compress. Oh, we can reuse the output buff too. So then here, we're going to call, shoot, what was it called? Compress. Oh. There's a decompressor too. Makes sense. And this takes the data, and we'll just specify, no, this is an image. Okay. So instead of doing this, oh, we can also reuse this. What would we call this? RGB. I wonder, hopefully this will create the image for us, right? Okay, we'll just copy their example code. Yeah, because it looks like it takes ownership of this. Actually, this won't do anything. Decompress. Oh, except the pixels are mutable. Okay, so we're going to have to create this image every time, but we will benefit from having this. Except there's no indovec. Oh, dude, I swear everyone uses a different type for dimensions. I still can't believe OpenCV used sign types. Like, oh, here's my negative 10 by 10 image, guys. Expected. Oh, duh, I made it the wrong thing. RGB pixels, RGB pixels. Except this has to be as mute slice. Huh? There we go. Okay, so basically what we're trying to do here is remove steady state allocations. So anything inside this loop that allocates, we want to move outside. So yeah, this is fine because we're creating everything on the stack. The memory is borrowed. And we're going to want to add a safety comment for this and say, yeah, because I think this doesn't do a deep copy. It should just actually refer to the memory. Yeah, it's just nice. This will be no copy. That's awesome. Yeah, so we have to take care of it. That's fine. One. Two. Okay, and then we want to use the compressor here. What does this take? This takes an image and a reference to the output buff. Good, okay. So instead of having this, that's own buff, right? Jpeg buff. Oh no, this is going to be should deref output buff. This should no longer exist. Yep, okay. Nice, and this is working. Deref to the rescue. And now we're going to have to create the image kind of like up here. Ooh, nice. So we can get this right from OpenCV. Hopefully this isn't mutable. Nice, okay. It's already a slice. Image U8. Image U8, okay. Actually, let's just have this inline. We don't need another variable here. Width, height, pitch is 3. Yep, RG. Wait, do we want RGB? What were we doing before? Oh, RGBA. No, we want to use RGBA. What's XRGB? Oh, it's ignored. Okay. Yeah, and then let's do the same up here with this image. We can just make this inline to clean it up a little bit. Yeah, we've totally way too many variables here. I want to try to improve the naming in a sec. Buff in meta. This should totally exist, right? Oh. Cargo Clippy. It got us good. This is a tuple. We don't need that. Nice. Let's hope this still works. Come on, baby. Woohoo! Okay, I'm feeling better about this. Yeah, so performance is really the next big thing I want to look at. It's interesting these timestamps are different. Because the problem is if our timestamps are messed up, we're going to have to manually move stuff around in VLC. Right, because basically the video that OBS is going to display is probably going to get the microphone data from the mic earlier, and if we don't do anything, it's going to be desynced unless the timestamps are the original capture timestamp, and then it can see the latency added by our processing and then shift the audio over. But yeah, otherwise we'll have to do some weird stuff for that. So how far? Oh, that's not bad actually. This is what? 100 milliseconds is kind of a lot, but also it could be worse. So yeah, let's comment out the rest of this and then do some benchmarking stuff. Okay, so we're printing out the total latency. And what is this inner loop? Actually, let's get rid of some of the indentation here. Yeah, if we get no detections, we'll just continue. So now we can get rid of one of these. And we can do this again. And this will add RGB, and that references this. And we don't have to allocate this every time. We can hoist this outside. This is no copy because we're giving it the data directly. This references this we can reuse. This is zero copy. This we can reuse. I don't like this. So this is already Luma, right? Should just be able to call this. Into vec. Yeah, that's what we want. Yep, okay. Nice. So we'll call this so then now we can do like, we can just do the same thing. This is no copy, that should be fast. I'm curious how long these conversions take. Oh, I wonder though if we're... This is decompressing, right? Depending on how this goes, we can just decompress directly into RGBA and save this conversion step maybe. So let's bench this before and after. Yeah, so this start will be after decompression. We'll include everything. No, actually, no, we want to include decompression. Okay. Then we get the data. This should be... Is this typed to be... it has to be a vec, unfortunately. We should be able to change that, though. Dynamic image. Huh. The problem is they probably make this where it can convert into anything at the cost of performance. Oh, so this is resizing, it looks like, into the models space. Yeah, I really don't like this type of code. So it looks like the model needs to take in YS. Is this still an image? Oh, it's just an array. So it looks like it's purely... I have never seen this weird indexing before. Yeah, it looks like it literally just takes an RGB image that's the same size as the other one. I wonder, it looks like it's just filling with a gray, I think. But yeah, if we have to resize, this is taking it by reference, right? Yeah. And so... Okay, we'll deal with the model stuff later. I just want to benchmark some of this. Find the things. This is fast. This is fast. Whoops. Bruh. Wait, what did I do to my OpenCV? Core size. Do we need U3? Where do we use mask? There has to be some other function here that's like as slice. Let's try this as flat samples. What does that do? Okay, that seems to work. We don't need to mutate this, right? We do, okay. So as flat samples mut. And as mute size, okay. Ah, okay. I guess we don't need the bounding box after this. We can simplify this a little bit. We have another variable called pixels, though. That's a little confusing. Okay, we're getting there. That's fine for now. Let's see what our latencies are doing. Ooh, I see some microseconds in here. That's good. All right. Oh, shoot. Let me... Ooh. This is getting a little ugly with the loop here. Yay! Go team. It'd be nice to do like actual statistics here, but oh well. So, okay, decompress is very fast. That's good. Source image. So this is pretty slow. There's probably a lot of unoptimized crap in here we can fix. This is fast. This is fast-ish. Compression's okay. And then this is fast. Okay, so the model eval is the biggest fish to fry at this point. So, let me think about this. I'm very curious though. So getting the RGBA source image, it's always about 1.8, 1.9. I want to see if we decode. This is, yeah. Instead of converting, let me commit this in case we have to go back. Yeah, so basically what we want to do is change any and all of the code in here to make it faster. So how are we going to do that, right? So the problem is we're decompressing into this, wait, where? Yeah, we're decompressing into this output buffer, right? And then we immediately take those pixels and then convert it from down here, RGB to RGBA. So I'm thinking this actually has support for decompressing directly into this. So we can just make this 4, make this RGBA, and then where we actually get this out, this is going to be RGBA pixels, and it has to be a little bit bigger. Okay, so then down here, yeah, we get out RGBA pixels. Start, yeah, so we call, I guess we call start.elapse twice, that's fine. So now RGBA pixels should be set, so we don't need this conversion. The thing is, though, we will have to create this. Okay, yeah, we'll have to create RGBA as this to just refer to this. I know we have the variable already, but we won't use it, and that's fine. And this is this, RGBA pixels, yep. That's what we decode as with height, and now we don't need this anymore. So now decompress, get Jpeg. Hopefully this will be faster than 1.8, but we'll see. Oh yeah, because this won't be a lot faster actually, because we're not stopping the timer. It looks like the conversion is only taking like 200 microseconds, right? Because we're going from 1.67 to 1.8. So I wouldn't actually expect this to be that much faster, but we'll see anyway. Okay. Okay, this does seem to be working though. That's good. Yeah, so this is about 200 microseconds faster, which is good. So now, probably the biggest fish to fry is in the pre-processing and stuff. So actually, we can probably simplify a lot of this. We know we're only going to be doing stuff on one image, and we know that the model has to take in an array. What does it need an array? Like, what are all these types? So this is an array base of whatever. We don't even use it though. What? Oh, XS underscore. And then I think we're using FP32 right now. We can also optimize that. Cow array. We shouldn't have to copy this though, right? Session run. Okay, now this is in ORT. Okay, so we probably have to keep this cal stuff. Because yeah, I guess the value could be copied. Okay, so yeah, it looks like we just have to create this array properly. And whatever processing we do here, we just have to do instead. I really don't like this loop. This is, like, best case, SIMD saves us. Worst case, it doesn't, and we, like, you know, do a bunch of allocations and stuff. So yeah, it looks like we're creating this. This is just simply going to be RGB scaled down. to floats. Yeah, it looks like, okay, so we're creating an F32 array, makes sense. And so, instead of dynamic image, we can just enforce that this is, oh, we don't even need the alpha component for this. Instead of dynamic image, let me think about this. Yeah, we can just take in, what's the type we have here? It's going to be like image buffer, but it'll be referenced, right? Because we're going to basically copy it into that massive array when we do the preprocessing. Actually, is there a way we could probably do this in OpenCV as well? So this needs to take in an array of F32. So we can actually just get rid of this preprocessing step and just take that in directly. That'll make a lot of stuff simpler. Ooh, what did I do? Oh, okay. The thing is, this image resizing is a little bit annoying. The thing is, we do actually want to actually, we can totally get rid of this task thing. Yeah, so the first step, I'll just remove this being a slice. This, what the hell is, what? Oh. So, this needs to be 1, right? Because the model itself supports doing multiple things in parallel. And we can get rid of task here also. Where do we get task? Okay, model. Yeah, so this is now 1. We're going to need, instead of IDX, this is all going to become 1. Oh, this is just, yeah, okay, this is just the fancy indexing for the multi-dimensional arrays. I wonder, hopefully we can, oh no, we have to do the image resize anyway, never mind. So we can't just mem copy this in. Resize exact. Things, why are we scaling if we're already going to resize, right? Oh, that's just calculating the scale, okay. And this is no longer a thing. This is in the loop, and now this is X, or I'll call it IMG. It's also not clear to me why we need to fill this array if we're just going to override it. I'm a little I have good reason to be paranoid. Oops. Whoops, where's my home row? There we go. Huh. What? Dude, all these ML guys, they write Pythonic like C code or Rust code. Like they're sitting here, you know, writing out, oh, XS. I have no idea what that is, dude. Okay, they fixed the formatting at least. I don't know where I deleted that. Wait, why is what? How is that a dynamic image now? Oh, duh. except this needs to be result of option is a little weird. Yeah, but then we can get rid of this unwrap in post-process. Yeah, so make this result dot next, and then this simply becomes let cool. And we don't need this. Or do we? No, we don't need this. Yeah, because we're doing the decompression directly from Jpeg. Cool. Let's make sure this still works. Ooh. That is not good. Array index out of bounds. Call unwrap there. I want to see the original. No, let's just do panic on abort. Always forget how to do this. Yeah. And we'll have to recompile everything, mostly. Yeah, in release mode, okay. Okay, at least we want a backtrace though. Yeah, I must have goofed up when making it. Nice. No, we want full, buddy. There we go. Format right, really. This isn't helpful though, what? So I'm guessing it'd have to be somewhere in here, right? They must not do track caller. Oh, did I just set this to index 1? Oh, that's really dumb. Yeah, obviously that's not going to work. Yay! Okay. Looks like it's still working. That's good. All right. So yeah, we need this resized. The dimensions are fine. We're working on getting rid of this reference. So this resize exec, does it give us back a dynamic? Okay, it does. So now this needs to be RGB, scale to floats, right? So what we can just do is take image RGB, right? We're just going to take this and then we can make it a reference. Do we want to reference? Nah. Yeah, we will, just so the borrowing doesn't get annoying. Or I mean the cloning doesn't get annoying. So this should still make this work. RGBU8, except now anytime we see a dynamic image, that becomes this. Post process, yep. And what is this comment? This comment does absolutely nothing. Yeah, a lot of this code is suboptimal here. All right, and we got to import this. So dynamic image, somehow it must dispatch this. Maybe it's like a common dynamic image, yeah. How is this implemented? I'm guessing this is a private function. Yeah, probably. But I think like RGB8, right? Surely this has a resize, no? Okay, that's fine. I guess we're just going to use dynamic image. Okay. Okay, let's see what that did to the performance. Ooh. Why does this take so long? Let's turn profile on. Yeah, it's these because we're doing a bunch of pixel stuff. This is understandable, right? I like how this is fast. Because this is the actual hard part. This is the ML stuff. This is just people writing garbage code. Okay, so I think the first step to help this run better in real time is splitting this up into two separate tasks. And so we can basically have one thread reading from v4l and then the other thread doing the actual processing. So, how should we do this? Let's do like, yeah, basically this entire loop we're going to pull out into a separate function. The problem is because it's mmap. That's okay. Maybe we can just decompress and then send the buffer over. Let me think about this. It's a Jpeg. No, that'll be fast to clone. We can just clone the Jpeg. That's fine. Okay. Whoops, what happened? Yeah, so everything up to the end of the inner loop. It's gonna be like function process. It's gonna return it's gonna take in and then what is this meta? Assume it'll never get disconnected. All right. So when we grab these, the output buffer stuff is going to have to happen here because we need those variables. And then here we're going to do if, oh, this is going to be Rx actually. So we're going to send to owned, unfortunately, buff and meta.clone. Hopefully we don't see that error very often. Oh, and then we need some of this setup stuff. So like width and height. This is no longer input. So decompressor, and then width, height, and some of the image stuff. Okay. Do we need the v4l device? Yes. We need the out stream at least. The problem is it's gonna have to be an arc or something, because this holds a reference to the device. But this makes an arc. Okay. So then why does this have a lifetime? What is this lifetime? Tick A. Oh, that's the length of the arena. So maybe then tick A is only needed. Oh, that's just for... Huh? Oh, it's... buffs? Oh, it's for the memory inside of the arena. Okay. So this should be fine. Yeah. And then down here, yeah, we'll pass in out stream. That should fix some of these errors. And then we also need, whoops. All right, we're getting there. Problem is, what are these types? Everyone uses a different type. Okay, it's using this because of this, but really these should be... And honestly, if you don't use a usize for your type, that's kind of a skill issue. Okay, and then create general allocations. This is going to have to go to the other thread. And the model. Hopefully this is send. And we'll do this with the model as well. What type is this? Oh, okay, it's just a YOLOv8. Oh, duh. What am I doing? Oh no, this is not a sender. Oh yeah, then most of these have to be mutable. Okay, nice. All right, let's see what this does. Come on, baby. I don't think we're doing a join handle. Wait, what? Oh, because it's an infinite loop, yeah. Oh, that's cool, actually. Okay, we probably need... or we could probably just create... can we just move the whole last device? Yeah, let's just do that. This is just a device. Yeah, okay. Comes after model. No more outstream. Nice, that still works. Except now, I wonder though if this is any smoother. That looks pretty good. Okay. Yeah, this pre-process is still annoyingly slow. I wonder what we can do about that. Should be able to put this in cargo.toml. Okay, yeah. Config, or whoops. Dot cargo. Cargo config. Okay. And we can just do Rust flags. This is a string. Yeah, I wonder if this is any faster. We might not have been getting SIMD for the stuff from the Rust image crate. Oh, wow. Okay, so I made the background darker, actually, and it made it better. I turned off the light in my room, so I just have the light kind of lighting up behind my monitor here that you can see. But this looks really good. It looks like I'm just here in the dark. There's only some weirdness if I move, maybe by my hair a little bit. This looks better. That's good to know, actually. Like, if I recorded in here every day with maybe some more light spread out so it doesn't reflect on one part of my face, this would be pretty ideal. This looks like extremely high quality. So yeah, let's kill this guy. All right. Still about the same. The thing is, now that it's split up to a separate thread, we can take, I think it's taking this long because it's, where are we starting the timer, right? I think it's actually syncing to, so I think when we write it out, oh no, that's not true either. Like this looks, you know what, let's just get rid of all the prints for now. And it's going to cry that all of these are unused. Down here. I just want to see if we end up dropping any frames. All right. Come on. Oh, and we have to turn this off also. This profile. This would be a good test of VLC. Like it should just hot reload once it starts running. Yeah, there we go. Oh, but now we're getting the empty print lines. Where do those happen? Here. All right, same thing with freezing. Looks good. Nice. It looks like we're not dropping any frames at all, which is perfect at 50 FPS. So really all that's left is looking at the latency. I think VLC is probably adding a lot of latency here. So yeah, actually let's pop into my streaming setup here for a second and try to get this bad boy added. So yeah, I have my typing up here, as you guys know. We're going to do a video capture device. Okay. Input. Ooh. Background cropped stream. Let's go. Loopback Jpeg. I wonder if I hit this, it'll probably, oh no, it's probably auto detecting it, so it works. Leave this unchanged. Color range. Yep. This looks, the latency here is already much better. And it should do latency detection, hopefully. It's not transparent, which is a little annoying. Jpeg, I think Jpeg does support transparency though, so it's probably, we can probably edit this here. Full. Is that any better? No, that looks worse. Huh. This is very annoying. Oh. Wait, did this crash? What happened? What did I do? I'm still recording, right? Okay. Did I mess with the properties too much? Loopback, Jpeg. Oh, maybe the blending mode. Go back to normal? No. What? Let me just try. That's weird. Is it, what? Oh, that's weird. No, that still isn't transparent. Okay, I mean that that might actually be what I want with it being transparent. So if I put this like up here now, that's too transparent is the problem. I need it like really on a dark background for it to pop then. I think that might have been what I did that froze it. It's still not right. Oh, that's cool. Oh, that's really cool. Okay, maybe this is the best mode. No, it's still... How does that look? You have to tell me how it looks on a... Because actually, most of the time, I'll just be in the terminal, right? With this black screen up here. So, maybe that will work. But yeah, I won't be able to figure this out quickly. I'll have to do some offline research. But yeah, dude, thanks for sticking with me to the end if you made it. We had a fun time. Optimization looks good. So I'm going to clean this up offline a little bit. This will probably be the end of this series because it's basically production ready at this point. So look for this camera being used in some of the other videos coming up. Hopefully that'll make things a little nicer. Or if like I'm talking through things, I can like use my hands and you'll be able to see me and all that. Wait, what just happened? Oh, it's detecting just my hands. We might need to fix that. Okay, that's interesting. Somehow that seems like it didn't happen before. Before it would detect my whole body, but I guess if my hands are big, maybe, then it's trying to grab onto one. But yeah, cool. Yeah, hit that like button if you made it to the end, and yeah, I'll see you guys around.